Alright, so I've been probing around. There's 5 volts and negative 5 volt rails. Those are fine. Capacitors and everything seem to be fine. This, I think is actually a current shunt. Without it, it immediately goes to, an overcurrent, alert. And yeah, everything seems fine. This is a quad comparator. This is basically just to drive the 7-segment displays. So the switch pretty much just switches in different transformer taps and then sends it through the bridge rectifier. And I've measured the voltages coming off the transformer, and they're pretty finicky too. They bounce around a lot. And I haven't been able to find anything on this transformer. I've looked up everything on it. And I put in Deltran, transformer, DL transformer, I think. But yeah, I can't find any way that I could get a replacement for it if something is going wrong with it, and that seems to be the case, because the voltage coming out of it is moving up and down like the output voltage was, quite considerably. And I'm not sure what would cause that aside from the transformer just being old and going bad. But I'm going to remove it, just so that I can test it not being connected and trace out where the switch goes a bit easier. And maybe with it disconnected, the transformer will work better, and maybe these switches joining a couple different transformer taps at the same time, just by some error, I don't know. But yeah, so we have, oops, what is it, 16 pins for this transformer to remove it. Yes, I am really hoping that it is just the switch that has gone bad, maybe. Although it seems pretty unlikely, but I do have one up here which looks basically identical. It's got a different color scheme, and the handle seems to have ridges on it. But it's only it's like $2.60. And free shipping from China. So it would take a while to get here, but that would mean easy fix. Yeah, I don't know if I could get this transformer anywhere. There's not really any information on the voltage taps, so finding a different branded replacement would be difficult, because I can't really tell what the voltages are supposed to be with them moving like that. I think that should be good. Might need a little bit of wiggling on a couple of them. Or more than a couple of them. Okay. Alright, getting nice and wobbly now. Let's not just this one. Get too much solder in that hole, but there we go. We have our transformer disconnected with a load of leads. And there we have the traces all leading to that 1-pole 12-position switch. One thing which leads me to think that it is possibly the switch, although I have no clue how the contacts are arranged inside, is I connected to, what is it, I think this connection, and just use the multimeter to beep it out. And I got continuity on all of these except for these pins 15 and 16 of the transformer when the switch was just in one position, which does not sound correct. But I'm not really sure. What we can do, the middle of the switch, the main contact comes over to a little via right there. And so what I will do is check that this is still recording. Yep. And just give it a little. Okay. So that seems good now. Let's randomly try a few. Okay, so the switch seems to be fine. Otherwise there would be a bit of an issue. And I'm just probing this transformer. And I'm not like an expert on transformers, but there's so many different taps on this. You would think they would not have continuity like this. Although, I mean, the resistance is changing considerably between them. For most of them anyways. So it could be just the same coil that's being tapped off of different points. Like the same winding, and they just tap off different points of the wire. I'm not gonna unwind the transformer to try and figure it out. So anyways, if we just look at this, I would like to find the negative of the transformer, just where all of the AC connections are connected to, basically, just through the bridge rectifier, just so that I know where exactly the main connection is, like that. We have 15 going off to this, which I think is just the 13 volts for the 5-volt power supply. That's fine. We have a current check coming from 16, and that leads all the way down here to this side of the capacitor, which is a 35-volt one, and it goes off to some other circuitry. So that's not what we want. I imagine it would be a fairly thick trace. This then goes over to the small capacitor. Alright, so I have my multimeter set up. I have this clamped to pin 16 of the transformer, and we will just go around and see if it's still giving us funky voltages. Connecting to 15 gives us a nice steady 11.8 volts, 12 volts. 14 is nice and steady. This is a nice, fairly steady 28 volts. 19 point some volts. 8 volts. 4.1 volts. This one, that's not bad, 13.4 volts. They were moving quite a lot when it was connected. Oh, that wasn't good. Sorry. And so I'm down to pin 2 now. 228 volts, it seems, decently stable. Pin 3, it's going up on this side. 102 volts. Or sorry, no, that was pin 1, then 2, which was 102 volt, or, yeah. Pin 3 now. .81 volts. It takes a bit, but this multimeter is a bit slow. Just under 18 volts. This seems to be 60 volts or so. This is 48, 49 volts basically. 37.5 volts, nice and stable. 17.4 volts. So it's interesting, with the transformer disconnected, the voltages on these are fairly stable. I'm not sure why this is reading voltage. But it's nice and stable, which is interesting, because that must mean something else with the connection to the transformer is causing it to act up. I've never released AC plus DC through RMS. I mean, it's just to show like the DC component from what I understand, but it's just yeah, this seems all pretty nice and stable now. So it sort of begs the question, what is there connected to the transformer when it's going to the bridge rectifier that is causing the voltages to fluctuate so much? I'm not really an expert or really real electronics engineer at all. This is just a hobby for me. I don't know, I like to think I try and do alright. But yeah, anyways, that's interesting. The voltages were all reading pretty erratic when the transformer was hooked up, with nothing hooked up to it. They're nice and stable, so it could be putting a small load on it, but I don't see how that would cause such a drastic amount of change. I should have shown you it when it was connected already. So pin 16, which is here. Goes down to the current shunt, over to a small via, and then to the output. Then it goes through this current shunt, that's after the current shunt. It goes down to this via and comes out over here. Goes past this capacitor into the resistor network in the quad comparator, and into this IC, probably just for the lower voltage, and pin 15 goes along to this diode, and then up to the positive lead of the axial capacitor, which also goes to the input of this 5-volt linear regulator, or I guess that's a linear regulator, voltage regulator. The negative goes underneath, and I think also into the quad comparator at some point, and then it also just goes to the ground. For the 5-volt regulator, it probably goes around somewhere to make this negative 5 volts. Although there isn't a negative 5-volt regulator, I'm not sure what they're getting that off of. It could be, I don't know what that is. 05 ACP on the middle, MC79L. I'm not sure what that is. It's probably just a transistor to switch on the LED. I don't think that's a little tiny 5-volt regulator. Negative 5 volt. And I'm not sure why they have negative 5 volts in this. Oh, well, probably for the quad comparator, actually. So I'm gonna hook this up again, and see if it still exhibits the same issues. And then I'm thinking maybe the only real issue with this could be the quad comparator. Something could have gone wrong with it, maybe, and it's causing some sort of issue or interference. I'm not really sure. I don't know much about integrated circuits like this sort of stuff. I've not really delved into it. Yeah, I've never really used any of those. I've never designed any circuits with those. I haven't really designed many circuits at all. But yeah, I'm sorry the camera was far out. I'm more just this is just sort of a talking to myself thing. Hopefully we're able to see a decent amount. But yeah, so I guess it's just time to hook this back in. And we'll see this still actually strange. So this end, possibly please yourself. Yeah, 1 second. Hold on, just 1 second. I will practice this way harder there. Okay, that's good. And then we start with the side. That's really easy. Yeah, it's interesting, but it's working fine. Not connected to the effect this word at all. Okay, so this. I'll put these spacers in that way it's the right distance. A little much in there. Just. And we have gain of security down first. Okay, I will I will do this and cut to when it's done. Okay, this is done. The transformer absolutely had to have longer leads when it was new and they were putting it in the factory. It is ridiculously difficult to get them in like this. And now they're all bent and askew and horrible, and I really need those pliers. And it's just not very nice. Anyways, just on the take a look at this. And get this yeah, it's still pretty static. And if I go from 16 to 8, I think I've been measuring before from 15 to this. I just like the same as this one. 69 volts. Should write down what these were, but it's not too bad. I can take my sort of 7 cycle time with those guys. I'm pretty sure I saw some of them when they got down fairly frantically though on the bar graph meter. They all seem fairly good now. Let's see. I need to know red herring. Or just not be, I'm pretty sure that's not something I've watched before. I should record that, that's it. I'm not sure that was the meter or the grass water. Let's see. Oh, no, it is easy. No, these are all. It's changing a little bit. It doesn't look up and down feel. It's probably nice. This is my video. I'll do that. So these voltages, I'll just turn the multimeter around this way. These voltages are all fairly stable. I don't have the resolution I normally do. This side seems to be the lower voltage taps. Whoa. That's a good idea. So the voltages coming off of here are fairly stable. And if I just pop onto this, bridge rectifier, it's putting a little, like 12 volts through. And if I go to these opposite corners, it should be giving me our DC voltage. Nope. Where is the DC coming out? Oh, I need to check that more. I'll trace out that a little bit more. I don't have that part down, but it's just really strange. The voltages coming out there are fairly steady. If I plop this in here. You can see that it just goes up and down very considerably. When really, I mean, in this sort of thing, I mean, it's for laboratory sort of stuff. You would want it to be pretty accurate, I would think, even if it is something that's not being used as a reference. That's the next step. What I'm going to do is just try out, find the traces of where the positive comes out, positive high voltage, and see if I can find anything relating to that. But yeah, this is just, I'm not sure what would be causing this. I mean, I don't think the quad comparator has any real influence on the rectification or anything like that. I believe it's just related to the voltage readout. There is an electronic shop locally, but they don't have any chips or anything like that, so I would be stuck waiting a couple of weeks for that to come in, if that is it. I mean, if I had one, it would be really nice. I might be able to scavenge one off something, but I wouldn't be able to be socketed, so that's sort of a no-go. But yeah, I'll sort of trace back where the positive for the high voltage comes off of this. And so if I just finicky there and then trace it back a little bit further. Although I can't imagine there is a whole lot that I can do. This is very puzzling though. My first real troubleshooting, pretty much. But hey, I think I can figure it out. If not, I have no clue. It'll be a doohickey that I have around until I can fix it or something. It's all through-hole stuff. I mean, this would be like kind of a nice kit power supply. Although, I mean, it's 250 volts, so it would probably be an expensive one with that transformer in it. Okay, so, I have gone and traced out just, the tracks, from the voltage output. and here it is. So yes, so positive goes through underneath, right to this connection of the bridge rectifier. Negative goes through and actually comes to this via, goes across to the current shunt, and also across to this side. Can't see the phone. This side of the bridge rectifier, but it also goes through under this via, which juts across and comes out. Oh yeah, right here. And this goes along here, bypasses that capacitor from what I can tell. Yeah, pops into this bridge, or this resistor network, and then that goes into the quad comparator, and it also goes into this IC driver. And I'm not sure if that's just being used as a common ground or not. Actually, I can quickly give that a test. Okay, so that is being used as a common ground. But what's weird is, aside from just going into that bridge rectifier, I'm not sure if the quad comparator has anything really to do with affecting the voltage of this. I really don't have a clue why it varies so drastically. I'm not even putting a load on it. I mean, that could be part of the issue, maybe, but even without a load, the power supply should be, you know, not that bad. Yeah, it's really puzzling, and I'm not quite sure what to make of it. I mean, maybe tracing the entire schematic out might help, but as it stands right now, I am just going to wait for these videos to be uploaded, and post in a forum. There's a link to these videos, and just a description of the problem, which is probably how you will find this video. So, hello. But yeah, this has me stumped. I'm sure some people are saying like, oh, it's so obvious, it's this thing. I don't know, I imagine there'd be a lot more issues if one of the trips was bad. I took them out and put them back in, just to make sure that they're all nice and happily set in there. But yeah, this has gotten me stumped. I don't really know what's going on. Voltages for the control are fine. The voltages coming out of here are fine. This, there's a little mark here, I think, that says 1 ohm. It's 0.78 ohms. A bit low, but that's got to be the current shunt. I don't see how that would do it. I mean, I don't think that the value of that would have changed over time. I could maybe try and find or make a 1 ohm shunt to replace that, but I really don't think that would have much of an effect on it. So yep, this has got me stumped. If you have any ideas or anything, please help. I mean, I could try to, you know, reverse engineer the schematic and draw it out, but I'm not very good with that. I've never tried that before. Okay, running low on space. Basically, what I was saying is I've never really tried to reverse engineer a schematic before. I might just make a mistake on it, which would not help at all. But yeah, this has me stumped. If you guys have any ideas or a clue what's going on with that, please tell me, because I am pretty much at a dead end. Thanks for watching.